Welcome back to my channel! So, for today's video, I want it to be something educational. I will be your teacher and you will be my students. But you better listen because when I teach, I am strict. For today's topic, it is all about Sir Isaac Newton's 3 laws of motion. Newton's first law of motion is called the law of inertia. Inertia, in simpler terms, is the ability of an object to resist a change in motion. Knowing this, the first law states that an object at rest will remain at rest, an object in motion will remain in motion in the same speed and in the same direction unless there is an external force that acts upon it. Furthermore, the first law was formulated by Galileo Galilei, generalized by René Descartes, then polished by Sir Isaac Newton. So, the key point here is that there are 2 scenarios. First scenario, if there are no external forces acting on an object that is moving with constant velocity, then it will remain in motion. Second scenario, if there are no external forces acting on an object that is at rest with 0 velocity, then it will remain at rest. However, if there are external forces applied to each of the objects in the scenarios, then the velocity in each scenario will change due to the external forces. To illustrate the first law of motion, here are examples. For the first scenario, take a look at this marker. It will continue its motion unless an external force acts on it. In this case, it is the book, which stopped the marker and changed its velocity. For the second scenario, take a look at this ball at rest. It is not moving and it has 0 velocity. But when an external force acts on it, in this case it is the air by the blow dryer, it will start to move, then changes its velocity. Look, it is at rest, but when an external force acts on it, it moves, then changes its velocity. So, Newton's second law of motion can be represented by the formula F is equal to ma, where F is a force that can be a single force or net force where all forces are combined, m is the mass, a is the acceleration. But here is a tip. You can also put this in a triangular formula where all you need to do is discover the part that is being asked for and it will give you the formula for that variable. So, in here, force is equal to mass times acceleration. Mass is equal to force divided by acceleration. And acceleration is equal to force divided by the mass. In this law, the force and acceleration are both vector quantities, which means they have magnitude and direction. So, once an external force acted on an object, it will accelerate in the same direction as the force. Also, remember that in this law, the acceleration of an object varies directly to its force, but inversely to its mass. If my brother who weighs 25 kilograms ran forward with a force of 50 newtons, then what is his acceleration? To demonstrate the use of the formula, we will solve the simple problem. So, using the formula, which is acceleration is equal to force divided by the mass, we just need to substitute the given values to the formula. So, acceleration is equal to 50 newtons forward divided by the mass, which is 25 kilograms, is equal to 2 meters per second squared. And don't forget the direction, which is forward, since this is a vector quantity, and that is the acceleration. motion is called the law of action and reaction. This law states that for every force of action, there is an equal force of reaction that is equal in magnitude but opposite in direction. So, if object A exerts a force on object B, then object B will also exert a force equal in magnitude but opposite in direction to object A. To demonstrate the third law of motion, here is an example scenario. If I am pushing a book down on a table with a force of 40 newtons, then in return, the table will also exert a force of 40 newtons but in upward direction. See how it applies the third law of motion? They do have the same magnitude, 40 newtons, but opposite in direction. One downward, one upward. Just an additional. Did you know that Sir Isaac Newton first presented the three laws of motion in a book called Philosophiae Naturalis Principia Mathematica in 1686? That's it, my lovies, for Newton's three laws of motion. I had fun today. And if you learned something, don't forget to like, subscribe, and share. Bye!